Okay, class, today we're going to talk about atomic symbols rather, and subatomic particles from chapter 1. So let's get started. So as you review your book and also the notes that I've posted, you may notice that we've been talking about the periodic table, and that the periodic table gives a list of elements using symbols, and here's a list of various ones you may see. Now, of course, you don't have to commit these to memory, but some of them that are a little bit more trickier, like gold, gold you would think is like G or GO, but actually it's AU, okay, which is actually the Latin name of the element. And lead is PB and iron is Fe, so on and so forth. You'll see this. Sodium is Na, so don't get sodium and sulfur confused. Sulfur is S, sodium is Na. Potassium is K, but P is actually phosphorus. So you're going to want to get used to this and get skilled at knowing these things. And so write the chemical symbol for the following elements. Just take a look at the periodic table I have posted. If you don't see it, go to Unit 3. It should be there. Oxygen is just an O. Krypton is a Kr. Sodium is Na. Potassium is K. So on and so forth. Lead is Pb. Iron is Fe. Iodine is I, and fluorine is F. Do want to make note of a couple things students struggle with. This fluorine is not Fl, it's just an F. And also the spelling is UO, okay? A lot of people like to do ORINE or OU, but rather it's UO, so fluorine. Okay, mercury is Hg, antimony is Sb, so on and so forth. So grab a periodic table and practice those. Name the element corresponding to the given symbol. So Si is silicon. Okay, Ca is calcium, and I'm just picking a couple so that you can see. But really, you can't do this without a periodic table, okay? Mg is magnesium, so I'm trying to point out some of the more difficult ones because a lot of students will get magnesium confused with Mn, which is a transition metal called manganese. Ne is neon. P is phosphorus, not potassium. So check out your periodic table that I've posted in Unit 3. You'll also find one in Unit 6, Unit 8, Unit 11, and Unit 15. And then atomic theory. It's the fundamental concept that all elements are composed of atoms. So we talked about atoms are very small particles, and they consist of protons, neutrons, and electrons. Most elements exist as individual atoms in their pure form, but some actually exist in the molecular form, so diatomic molecules. And that's going to be these listed below. You will need to commit these to memory. H2, N2, O2, F2, Cl2, Br2, and I2. So we're only talking in elemental form. Whenever they form compounds, they can exist as just a singular, such as H2O. You know, that's only one O right there, not two. But if we're talking about what we're breathing, oxygen, we're talking about O2 gas because it's the elemental, or rather the molecular form. It's how it naturally exists. How do I remember this? Well, this is really silly, but I just say Hunkelbrief. Hunkelbrief. It's a made-up word, but it helps me remember. Honcl. Hunkelbrief. And so that gets you all of them right there. It's kind of rearranged, but Hunkelbrief. That's what goes in my head whenever I think of the diatomic molecules that exist on the periodic table. So try to commit those to memory. That'll help you. Here's our 3 subatomic particles. You'll see these in varying ratios in every single atom on the periodic table. So proton is positive, easy enough. P and P, proton positive. Neutron is not negative, okay? Neutron is neutral, so get the NEU. Neutron is neutral. Okay, and both of these really tiny subatomic particles, meaning smaller than atom particles, which actually make up atoms. These 2 protons and neutrons you'll find in the nucleus of an atom. Okay, and they're rather large compared to the final one, electrons, which are very tiny, but they carry a negative charge. Electrons are negative and exist in the electron cloud outside of the nucleus, okay? So you have protons, And you might have neutrons, which are neutral, which it gives your nucleus a positive charge. So we'll call this the nucleus. Okay, and then outside the nucleus would be your electron cloud. We'll just denote that as an E minus. And so according to this, there are 5 electrons, so 5 negatives in the electron cloud. Let's call the red dots in the nucleus protons. So that would be 5 positive charges. So the nucleus is positively charged. The electron cloud is negatively charged. But since there's 5 positives in the nucleus and 5 negatives in the electron cloud, that would make this a neutral atom. Okay, plus 5 minus 5 gives you 0. So there's your subatomic particles. I ask that you do not commit the masses to memory, but I do want to point out that the protons and neutrons are much larger than the electrons. I know they seem small still, 1.673 times 10 to the minus 27th, but whenever you compare it to the electron, which is times 10 to the minus 31, that's a large magnitude of difference, okay? But you can call the relative mass of a proton 1, neutron 1, and if you were to compare that to the electron is 0.00055 times the size. So it's really small. And you can just remember proton positive, neutron is neutral, and electrons are negative. And so I tried to briefly describe what an atom looks like with a nucleus and electron cloud. And so right here would be the nucleus where the protons and neutrons are hanging out. And then all around this, kind of encasing it, is your electrons. They're just kind of here. And the electrons are going to be involved in bonding, as we're going to see in the next couple chapters. Okay. And as you know, I did draw the electrons in discrete orbitals as if a planetary kind of model. But what scientists have since then figured out is that that's rather not how they hang out around a nucleus, but they occupy random regions around a nucleus. Not necessarily orbiting as shown previously. So looks like that takes care of today's little lesson. Always email your instructor if ever you have any questions.